This conference will now be recorded.
Good morning, all of you.
Hello, sir.
Hello, sir. Good morning, all of you.
Yes, it is visible, sir. Okay.
Yeah. Okay, okay. Good morning, everybody. Since nobody is, first I will welcome, then proceed to the-
మరి ఇది కూడా రావట్లేదు మరి ఇది మూత రావట్లేదు అది రింగ్ అయిపోయింది
Hello.
Hello, sir.
Sir, just
సార్
2
జస్ట్
minutes, sir. Again.
సార్ జస్ట్ 2 minutes సార్ సార్ విల్
Okay.
ఇంట్రడ్యూస్ యూ
Right. And 1 minute. How to share this screen?
సార్
Already I have shared. Is it visible to you? I have shared my screen actually.
ఇట్ విజిబుల్ సార్
The slide is visible. I am asking. Huh?
Sharing the screen.
Yes, sir. Your screen was presenting,
Slide
sir.
మీకు
Yes, sir.
slide కనిపిస్తుందా?
కనిపిస్తుంది సార్.
కానీ వస్తుంది కదా? Right.
Yes, sir.
Just done. Right. Okay. Thank you.
Good morning, all of you. Why so dull you are looking today? So, I welcome you for this session. A webinar session is going to be present for you, that is on innovative materials in civil engineering and latest technology in construction practice to bridge the gap between your academics and the practices going on and research work is going on outside. So to bring closer to you and this bridge the gap, this session has been arranged for you, especially for final years. It is very useful, and even though third years also is a very important topic. So that is innovative civil engineering materials. So lot of materials are there already existing, and some of the new materials also coming to the market every day. So being a civil engineer, you must know what are the things are available and what are the developments are taking place. For, for this purpose, so this webinar has been arranged, and I just introduce our today's guest and faculty. So he is Mr. L.V.PRASAD, and he is working associate professor in NIT Silchar. So that is in Assam. So he has been working, that is 18 years of experience, and having research work in new materials in concrete, geopolymers, self-compacting concrete, recycled aggregate, and fiber reinforced concrete. And he has made so many research publications in international and national level, and so many conferences also. And he is also membership got reputed this membership member of American Society of Civil Engineers, ASCE, ISTE, and IEI, that is Indian Institute of Engineers, and member of Indian Concrete Institute. And he has earned most awards also, and in his UG level and PG level, and he has the best teacher award also in the in the literature, and he has he has done so many administrative positions also. I don't want to extend more, so he has done this one and departmental positions, and has been made some international visits to present some conferences and attend to the this Malaysia, Singapore, and all these things. So once again, because of apart from this, I want to express one thing about him. I know him for the long 10 to 15 years. So he is actually he is working in the department, that is irrigation department in Kabul, INPD. So even though he is working in the government sector, because of his interest in teaching, so he used to come to the guest lectures, even though he is getting very good government salary, but because of his interest, he is whatever his research work he has done his research in NIT Warangal. So we want to share the knowledge for the students. That's why we used to conduct the most of the these classes, taking the classes for the students in around that Kabul and shown interest in that is on teaching side. Because nowadays the students, most of the members are not interested in teaching. We are seeing also. Coming is also interested or interestingly coming to this field, but even though he is having government job, he left that job and joined in Silchar when he got a teaching assistant professor. So he left the job and joined in teaching. So he is having that interest in teaching. So he is continued, even though with a very good job in he was working in assistant deputy executive engineer. So even though he left that post and joined in that. So I welcome you, Dr. M.L.V. Prasad,
Thank you, sir.
for telling you. Please utilize this session. Please listen. He is also very good speaker and very useful things. Because you please maintain silence. We request you. Otherwise, those who are interested also cannot listen. So you please maintain the silence and utilize this opportunity for your development. Thank you. Thank you very much.
Okay. Thank you, sir.
Okay, sir.
So shall I start now? Sir, can I start?
Yes, sir.
Yes. Thank you. Thank you for giving an opportunity to share my ideas and research innovations with the young engineers of PACE Institute of Technology and Science. Initially, I am very much thankful to the Chief Patron, M. Venugopal Rao sir, Honorable Chairman and MLA of your college. Then Patron Dr. M. Sridhar, Honorable Secretary and Convener of your college. Then Chairperson Dr. GVK Murthy Garu, Professor and Director of IQAC, and Convener of the program Mr. Ganesh Naidu sir, HOD Civil Engineering Department, and organizing members Dr. L.V.PRASAD Reddy sir. Hello, hello. Can you hear me? Hello. Yeah, some network issue, I think. Some network issue
Yes,
is
sir.
there, na? Okay, okay. Okay, no problem. Online, this will happen sometimes. No problem. Are you able to hear me?
Yeah, yes, sir.
Okay, right. Thank you. So once again, I am very much thankful to the organizing members, Dr. L. Ramprasad Reddy sir, Dr. M. Durga Varaprasad, and Mr. E. Babu, and Mr. SVN Anil Vamsi, and all other faculties, my dear students. It is a very great pleasure to me to share my ideas with all of you. And uh, I am sharing my slides. Is it visible to you? Just see. Is it
Yes, sir.
visible? My slides
Yes, sir.
visible? Okay. So uh, nowadays uh, we have to know what are the innovations going around us, and we have to know what are the new research areas it is coming, and always we should update with the system. Suppose example I will say, when we have started research, this much of opportunities are not there. Whatever the facilities we have, see, by sitting there only, you are able to contact with me, and you are able to share my ideas. So that is the technology we have now. So we have to utilize the technology. Not only a civil engineer, all the engineers nowadays, computer skills are very very important. Whatever the research we are doing, finally it is coming into the application. So when you are going to give a application, and if you want to see in the innovative, always you should be strong in the research with respect to computer aided design. You have to know, see, best example I will say, now if you want to contact, you have to know any software like this, Google Meet, or any some software, we have to know how to connect from from the far place to contacting with you. So innovations in civil engineering materials and latest R&D in concrete technology, we are going to discuss here. So actually, I am working in NIT Silchar, and I am also the we have IIC Institutions Innovation Cell, and I am the ambassador for Civil Engineering Department. Because nowadays, not only teaching research, you have whatever the research you are doing, that you have to business. That means you have to sell yourself. Only if I say I am good in teaching, I am good in research, it is not sufficient. You have to say what research you are doing and how you are selling yourself. Okay, is it visible, these slides? Hello, hello, these slides
It's
are
okay, sir.
visible?
Yeah, it's
Right,
okay,
right,
sir. It's okay.
right, right. Okay, so mainly here I am going to
Sir,
concentrate mainly on the
sir, only first slide is showing, sir. Second slide is not coming.
second slide is not coming now.
Yes, sir. Ah, okay, sir. Okay, sir.
Okay, then I will go on changing the slide one by one. That's why I am asking. Okay, now it is visible now, timeline of concrete and cement history.
Yes, sir. Yes, it's visible, sir.
Okay,
It's visible.
see, if you see, I will discuss here basically what is the history of the concrete, and now where we are and where we started. Okay, right.
Okay, sir.
And if you see, in the Romans first invented the concrete, hydraulic cement based concrete. Before that, no cement, only we are going to use the mortar and lime mortar. So with that only we are going to do. But after that, there is a improvement in the concrete technology. Instead of lime mortar, slowly we came into the cement mortar. Okay, just 1 minute. Hello sir. Sir, వీడియో అది నేనైతే స్విచ్ ఆన్లోనే పెట్టాను సార్. ఒక్క నిమిషం, మళ్ళీ ఆఫ్ ఆఫ్ చేసి ఆన్ చేయనా? ఒక్కసారి చూస్తా ఉండండి. ఆహా! ఓకే, ఓకే. ఆహాహా! యెస్ సార్. యెస్ సార్. నా కెమెరా ఓకే, ఓకే. ఆఫ్‌లో ఉంది. ఆన్ చేశా. రైట్ సార్. హుహు. హ్మ్. ఓకే సార్. యాహ్! So now we will discuss about the concrete. So if you take the concrete, concrete is the combination of steel, cement. Hello.
Okay, sir, you can continue, sir.
Okay, okay, right. Actually, if I go to the presentation mode, you are not able to see na. Let us now it is okay.
Sir, everything is okay, sir.
Right, right, thank you. So basically, we in the particularly in India, we are very much habituated with the concrete. Construction means actually in India we are going to do with the concrete only, right? So I think these slides are not going to show. So let us see what are the advantages or recent advances and trends in the concrete technology. First we will see, then after that what are the different methods of making new concretes, because nowadays only working with the regular cement, sand, coarse aggregate is not allowed, because you know that if I want to work on the concrete, then I am indirectly I am going to produce if I am using a cement means indirectly I am going to produce the carbon dioxide, but it is not useful, not it is very harmful to the industry. Okay, so that's why we have to think for alternatives. What are the alternatives I can go? So here if you see, I can go for the, initially we started with the cement motor of lime motor, then we went to the cement concrete, because already because necessity is the importance of the invention. So based on the necessity, slowly we moved to the cement concrete. Afterwards, even the regular cement concrete, only if it is giving M20 grade, M30, M40, it is not sufficient. Then we went to the high strength concrete, then high performance concrete, then fiber reinforced concrete, like that, self compacting concrete, self curing concrete, then geopolymer concrete, and all these things. So we will see the all the updates in the concrete.
Excuse me, sir. Your
Okay.
screen is not visible, sir.
Yes, green.
Okay. Now it is visible, sir. Okay, sir.
Okay, see, if you take the fiber reinforced concrete, so what is the advantage of fiber reinforced concrete and where we will use it, I will tell you first. Before that, we will see what are the different fibers, types of fibers we have. So we have steel fiber, we have glass fiber, asbestos fiber, polypropylene fiber, carbon fiber, armored fiber, like that. So many new things are coming. Some are useful in the micro level, some are useful in the macro level, like that. So basically, wherever I want to develop the tensile strength of the concrete, I want to increase the modulus of rupture, Young's modulus, flexural strength values, then automatically I prefer the fiber reinforced concrete. Suppose if you take the example of you are constructing some slab, and there if it is a there the rainy period is very high, there is a chance of leakage of water from the slab, then you can go for the fiber reinforced concrete. If you use the fiber reinforced concrete, the advantage is it is going to arrest the cracks, and it is going to make a concrete in such a way that there is no leakage of concrete, because fibers are very good in arresting the cracks, and they are going to have very good bonding with the concrete. So like that, this is going to be useful. If you see the fiber reinforced concrete stress strain diagram, this after ultimate, if you see the area under this curve, if you take A1 and A2, so indirectly we are improving the ductility of the concrete. Ductility means toughness of the concrete. Indirectly I can say toughness of the concrete, total area divided by A1 plus A2 divided by area of A1, if you say, that will give you the toughness of the concrete. So uh, like that, here you can see without fibers it is going to be very brittle, but with fibers this is called rupturing of the concrete, or flexural rigidity is going to be very very improved by utilizing this fiber reinforced concrete. So for that, nowadays so many types of fibers are came now, even in the FRP, means in the retrofitting techniques also we are going to use these sheets. So this is a very wonderful material which is going to use you the improve the tensile properties, modulus of rupture, flexural properties of the concrete. Okay, so based on the requirement we are going to see whether fiber reinforced concrete is used or not. Next, if you come to the high strength concrete, see already we discussed about the normal strength concrete. See, in the normal strength concrete, we can achieve up to a grade of M50 or M55. After that, I am not able to develop the concrete. Then, so suppose if you are in metropolitan cities or where the land cost is very high, in that cases, definitely we have to go for high-rise buildings. Let us say G plus 10, G plus 20, G plus 30 like that. So if you are going like that, automatically you have to develop a high strength concrete which is going to have the higher strength characteristics. Mainly in the columns we are going to use M60, M80 like that. Suppose if I am constructing a in New Mumbai some construction, then definitely it is going to be a G plus 50 or G plus 80. I cannot waste my land. So for that purpose, definitely I have to think about the high strength concrete. So in case of high strength concrete, what we are going to see, obviously there are certain conditions. If I want to get a high strength concrete, I have to maintain the low water cement ratio. Then addition of fine pozzolana materials like silica fume, fly ash, GGBS, metacoilin, like that, rhesus gas, like that. We have to add some pozzolanas to improve the pozzolana activity and to get the high strength concrete. See, only if I use using the cement, if I am developing the strength, then automatically it is going to be not economical, and even there is a burden on the concrete also. Only cement is increasing, then you are going to see so many other problems. But if you utilize this binder, because it is a byproduct, if you take a fly ash or ggps or anything, it is a byproduct. So if you utilize this, you are going to get two ways of solution to the problem. One way, you are showing you are utilizing the waste, and another way, you are reducing the cement content and you are utilizing it as a binder, so that durability properties are going to be increased when you are adding these pozzolanas. Because of this pozzolanic action, strength, there is a improvement in the strength, and additionally there is a pozzolanic reaction, so they are going to be very useful. Only whatever the cement it is required for the hydration process, you use only that much of cement. Then afterwards, then you go for uh, using this uh, pozzolanic materials. Okay, I think right. So now, if you go to the high strength concrete, how to prepare it? What are the simple thing? What is the difference between the normal strength concrete and high strength concrete? If you know, see, basically, if I want to get more benefit, means definitely there should be some limitations on the material usage. Obviously, when I am saying it is used for the high-rise buildings, then there will be the sizes are going to be slendered. So obviously, there is a limitation on the coarse aggregate content. That means the size of the coarse aggregate is going to be reduced maximum of 16 or less. Otherwise I will go for the 12 only. And definitely I am going to use the supplement ECS materials like fly ash, silica film and all this, but different dosages I will fix based on the different type of the material. Suppose if it is a silica film, because silica film is going to have the high water absorption capacity, high range range admixtures are used in case of silica film added as a super plasticizer. That's why its dosage is only 5 to 10% only. But if I am using fly ash, I can go up to 20 to 25%, even up to 30% also I can use. Like that, based on the different silica film, fly ash, ggbs, all are ashes only, but there is small change in the collection process. How you are collecting, based on that they are given a different name. All are ashes only. Nowadays, even this JSW is using the slag also. Slag is also one type of a ash. But how you are collecting, how the fineness is there, based on that we are giving different naming to these materials. Obviously, I told you, in case of high rise buildings, Let us say if it is a G plus 80 or G plus 100, strength is the very very important parameter. So obviously, in that cases there should be a reduced size in the member, and early stripping of farm work or lowering of construction cost, all these things are going to be there. All these are the very important parameters. So that's why we are going to uh, keep in mind all these. And there are different methods of developing high strength concrete. Even if you see is 10262, whatever it is, newly developed, so in that they have given the option of developing the concrete. But earlier, by using our is 10262, see, as a student, what I will say is you should be thorough with the codes. What are the codes available? Particularly if you say civil engineering is very easy, but if you know the source of material, and always I can recommend the civil engineers, though they are going to have the better opportunities when compared to other than these other branches. Why I will say? Because see, nowadays computer science is the common language for every person. Even if you example I will say, suppose if I want to develop the mixed design, even though if you are developed a high strength concrete or self competing concrete, if you go in manual way, it will take so much of time. Suppose if you use some computer language, or if you write some coding to develop the mixed design, same procedure, just if you give the input, it will give the output. So like that, you start with the, because you are third year and fourth year students, so my sincere suggestion is you start with a simple thing. First you try to write a program for the mixed design of is 10262. Let's just take a M40 grade concrete. What is the data you are giving as a input, and for that input you try to give a because if I give the properties of the cement, if I give the properties of the coarse aggregate, if I give the properties of the fine aggregate, then water cement ratio, all these things, one by one, step by step, we are calculating all this. So you try to prepare a Excel sheet first for the mixed design. There also just you write prepare a Excel sheet, so that if you go on changing the grade of the concrete, suppose if you say M30, then target is going to be 38 or 37, something like that. You give the input data, specific gravity, then water absorption, then all the input data, generally whatever we will give, you write the steps in such a way that automatically the calculations will be there, and it will show the, finally it will show the mixed proportion. You try with the Excel first, then after that you try in the C language, because in the first year all of you are learning the C language. Why I am saying is, nowadays, see, no one is going to use the manual calculations in the consultancy, or in, if you go outside. Even if you, after completing your BTech, if you go anywhere for job purpose or in the placement also, definitely they will ask you what languages or what softwares you know. The reason is, nowadays you should have the knowledge of your background science, engineering, but that is going to be applied in the user friendly mode. User friendly mode means, definitely I think all of you are having laptops, almost
Yes, sir, it is.
all of you are carrying your laptops, na?
Yes, sir. Yes,
Yes.
sir. Yes.
So because if you, if we are giving any project to you, or you are doing anything nowadays, almost we are habituated to the computerization, because it is easy to work. Same, suppose if I want to develop a M40 grade mixed design, it will manually, if I want to calculate, it will take so much of time. Instead of that, if I prepare a Excel sheet, and if I have the Excel sheet with me, if I am giving the input in 5 minutes, I will get the output. Like that, you learn the C language also, because in the first year it is there. From, if you know the C language, then learning the this MATLAB coding is very easy. Because why I am saying is, whatever the typical problems are there, let us say whatever the structure analysis 1, structure analysis 2 you are learning. In the structure analysis 1, statically determinate structures we are learning. In structure analysis 2, statically indeterminate structure, that slope deflection, movement distribution, canis, whatever the, you know how much lengthy procedure is there. But if you are able to write the coding in the MATLAB or coding in the C language, within fraction of seconds, whatever may be the structure, even if it may be a G plus 3 building frame, or G plus 5 building, if you are able to write the coding once, what if you are go on changing the structure frame also, it will give you the results. But just you have to give the height of the floors, how much individual floor is there, how many bays are there, each bay how many beams are there, what is the beam size, like that some coding is there. So if you give this coding in the MATLAB, then automatically it will give you whatever the generally you are analyzing the frame means for the shear and bending purpose, so directly it will give you the results. Why I am saying all these things is, see, civil engineers, we are now we are saying that there is a less placement. No, nowhere there is no less opportunities. We have the opportunities, but you have to upgrade accordingly. If you say simply I know the theory, I know only practically, I know manually, but I do not have idea how to apply it in through computers, but no one prefer you, because nowadays everything, even a small kid knows how to operate the mobile. So that's why you should convert your basic things to the user friendly mode. You have to learn the coding. Similarly, you people to should know the AutoCAD. Otherwise, whatever the design you are preparing, if you want to give the design details in manually, it will take so much of time. So if you know the AutoCAD, it is easy to modify the existing drawings or preparing a drawing. Okay, then similarly you have to learn the STAD also. STAD is very 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 important for you people. Because let us say if you go, if you attempt for a placement or if you attempt anywhere for job, definitely they will ask the basic civil engineering background analysis from questions design some, but they will ask you this application, whether you are able to apply this whatever the known subject through any software. You do you know the STAD or do you know the ETABS? At least one software at a BTech level, STAD or ETABS you have to learn. Then coding language, one C language and one MATLAB. So that, because why I am saying is, when I am doing my research, SAR knows very well, we are working in self compacting concrete, but for preparing a self compacting concrete, to know how these basic tests and all that, we will discuss here about the self compacting concrete. After the high performance concrete, we will discuss about the high self compacting concrete also. But why I am saying is, nowadays, see, when we started with the self compacting concrete, at that time, preparing a self compacting concrete, it is very difficult to prepare, because I have to get the equipment, I have to do the basic test. um, Experimentally, if you want to develop the self compacting concrete, so many experimentation and so much material things are required. But nowadays, if you use the ANN, artificial intelligence, neural networks are there, artificial intelligence networks are there. So if you use the neural networking networks, if you have the, because through the net we can get so many existing proportions of the mixed design of say SEC. If you train it with suppose if 100 samples are there, if you train it with 70 samples, then if you ask it if you test it for the 30 samples, if it is giving the results, then directly whatever may be the grade of the SEC, simply just by writing a single program, it will take maximum of 1 hour, you can develop any grade of self compacting concrete. That is the technology available now, artificial intelligence. So if you want to go through the artificial intelligence, before that you have to know the soft skills like STAD, MATLAB coding. If you know this, because in the MATLAB itself we have a small tool for the ANN, it is very easy to use that tool, and even easy to publish also, even easy to prepare the mixes. So like that you have to upgrade yourself. See, like that, whatever the how the concrete is upgraded from high strength to high performance. So I will say mainly the problem, see, we thought earlier to go for high rise buildings, definitely the reason is, see, just best example I will say, suppose if you are using a new if you are purchasing a new laptop, what you will see, what is its storage capacity, what is its speed, what is its memory, like all these things you are going to see now. What is the operating system, what is the memory, what is the storage, because all should be at the same grade level. Suppose if you are purchasing a new laptop, but its RAM is only 256 MB, is it useful? It is not useful. We have to upgrade the RAM also, ROM also, then storage capacity also, then software. user friendly, this Windows operating, everything should be at the same level. Similarly, when I am going to develop the concrete, only there are so many developments in the steel side. There is no limit for the Fi value. You can use a Fi of 415 or Fi of 550, even 1000 also you can use if it is a pre-stressed concrete. So similar to that, but earlier we have a bar on the FCK value. We cannot go for more than M50. That means 55 MPa or 60 is the maximum. After that, we are not able to develop even in India. So now our Indian code is also revised. 10262 2016 is also came. 2019 also, I think they have given some modifications. So if you see there, now even by just using our Indian code also, we are able to develop the M80 grade concrete. That means mainly when you are developing the RCC structures, FCK and Fi2, these two things are important. If you are able to develop the FCK, then automatically F button on the Fi is going to be reduced. That is the reason we will think for the high strength or high performance concrete. So basic difference from the high strength to high performance is, see, if you are going for the high strength, the problem is it will take the maximum strength but up to ultimate only. That means let us say we all know that the strain of the concrete is, ultimate strain of the concrete is 0.0035. So up to that it will behave very nicely, but after that, because it is a concrete, after ultimate, if you see, if I am using only high strength concrete, it is going to have the sudden failure. But this sudden failure is not recommended in our structure, because any structure, if it is very brittle, and high strength concrete is more brittle than the normal concrete. So one way we are getting the high strength, but performance wise, if you see, whenever there is a problem, so we are facing so many problems with the high strength concrete. That's why we have to think about the high performance concrete. Not only strength with respect to durability, it should have a long life. Strength should be for a longer life. It should give a stronger concrete mixtures, would be more durable, did not provide to be right, hence performance criterion was adopted. That means not only strong, it should be durable. A man with a strong, it should be durable, he should be, he should live for a 70 to 80 years. Other than that, he is a gym man but he is going to die by 40 years or 50 years, means it is useless. So like that, high strength along with the performance, then durability into came into picture. So what they have with the, see, all this is with the experience. Once you are developed the concrete for the, once you are developing this concrete, right, yeah, after developing the high strength concrete, we have a lesson that not only strength, we need the performance. Then again they have done the exercise, then they see what are the precautions I have to take to develop the performance of the concrete to improve the, then again they have given a bar on the, they have given some limitation on the, there should be a limitation in the value of the cement. You should not cross 450 kgs per meter cube of concrete. That is given in the IS code. If you see any mixed proportion, if you are preparing with respect to from the durability point of view, simply it says you have to maintain a cement of 450 kgs per meter cube only. Then similarly, like that, so many precautions and so many suggestions it is given before going to prepare the high performance mixes. Then obviously high strength or high performance, we are going to have the lower water binder ratio. See here I am saying lower water binder, not water cement, because obviously whatever the cement it is required for the hydration process of the, and to gain the strength, that much of cement only I am going to use. I am not going to use cement as a filler material or as a fine material. Whatever the minimum cement it is required for the hydration process and to get the strength, that much of cement only I am going to use here. Then other I am using it as a binder. I will add the fly ash, or I will add the GGBS, or I will add the silica film. Like that, there are some changes I have done in the preparation of the mixes, and I am going to see that I am able to develop the high performance concrete. Obviously, uh, see, whenever if it is not durable, you can see here what are the problems, durability problems. abrasion resistance, blast resistance, permeability should be impermeable. Actually, concrete should be impermeable. Then there should not be any carbonation problem and freezing and thawing resistance. All see, durability criteria means actually what happens is if the concrete developed, definitely it goes on some deterioration with the life, with the time concrete will be under the deterioration. If it is continuously deteriorating, obviously you will see the durability problems. What are the durability problems means? All these are the durability problems: alkali aggregate reaction, sulfate attack, acid attack, then so freezing, thawing, abrasion, all these are the durability problems. So we have to develop a concrete which is going to be resisting all these. And even in this adverse environments also, if sulfate attack is also there, suppose if you take the seashore areas, if the construction is nearby any seashore area, or nearby sea, if you take the IIT Bombay or NIT Suratkal, they are very nearer to the sea. Obviously whatever the buildings you are constructing, they are going to have the sulfate attack problem. This sulfur is going to form a layer in the surface of the walls, so that will create the problem. To how to rectify this, how to prepare a concrete that this durability criteria we have chosen in the development of high performance concrete. Obviously IS 456 is given based on the see, based on the environmental exposure. If it is mild, moderate, mild, severe, very severe, like that, they have given some conditions. Based on that, we have the clear cover. Why we are giving? So with this, what happens is directly the concrete or steel inside the RCC is not going to be exposed to the weathering, so that there are no durable. If it is exposed to the air or water, if it is exposed to the air or water, automatically the durability problem starts. So that's why we have to see that they are not going to be exposed to the weathering, and all these issues we have to address before going to prepare any concrete. So we initially started with the lime mortar. So lime mortar is good actually, basically, but it will take so much of time. You have to grind it so many number of hours, then only you have to use it as a mortar. Then you are using it. Strength wise it is giving, but time wise preparing the slime mortar, it will take so much of time. So that much of time is not available with us now. So that's why we developed the cement. After that, if you are in normal strength concrete, then again we thought that if I want because in multi-storied buildings, if I want to design, normal strength is not sufficient, I have to go for high rise buildings, then high strength concrete. Then after that, in the with the failure we have seen, it is going to fail suddenly. There is no time gap, and it is not durable also. It is giving strength, but it is not durable, then it is useless. Then we thought for high performance. Then even high performance is also good, performance wise it is good, but the problem is cost point of view. Because whenever I am saying I am developing a high performance concrete, see, definitely there will be a skilled labor for developing high performance concrete, because so many technical terms are there in developing the high performance concrete. Technically skilled labor is required. Super mineral admixtures are there, chemical admixtures are there. Then I have to prepare it with the good material, and I need technically qualified labor. But nowadays, even getting a material is easier than getting a labor. Nowadays 700 to 800 per labor per day. So even if you use the 6 labors per preparing 1 meter cube of concrete also, the per meter cube of concrete around 10,000 we are spending nowadays. Around 10, that is minimum value I am saying. But with this, if I want to construct a multi-storied building with this number of technically qualified labor, it is not going to be economical. Then we thought, and there is no compromise with respect to durability. I should not compromise from strength and durability workability point of view, but I should get a good results. Then we this self compacting concrete is developed by Hazim Okamura in 1986 in Japan. So he is developed a concrete mixed proportion in such a way that just with the in the at the preparation of the concrete itself, we are going to see that the number of labor is going to be used less in the preparation of the concrete, and no need of any compaction. because for all these regular concretes, whenever you are going to pour it in the required shape or in the required structural element, we have to compact it. But for compaction, again, you need the labor, you need the machinery, so many things are required. Suppose, and that too, the problem in the practicality is, see, you are expecting that this is going to give a MIT grade concrete, but the problem is, uh, actually what happens is, you are expecting that it is going to give MIT strength of MIT. When it will give, you are able to use the quality assurance of the material, then you are assuring the mixed proportions, whatever you are given, that same they are going to maintain, water cement ratio, all these things, super pressurizer, all these things, economical. See, you cost wise you are keeping all these things, but if you are not able to do them properly technically, and if you are not vibrating it, because vibration is the 30% weightage is there for vibration. Without vibration you are not going to get the strength of the concrete. So definitely you have to vibrate it thoroughly. The vibrating means we are trying to densely pack it, and we are trying to remove the air voids and water voids. If you are able to remove all the voids, then it is going to be densely packed, then automatically it will give the best results. So for that also you need the labor. Practically what happens in the small constructions, or even in regular cases also, they will neglect, because if you want to use the vibrator, you have to use the petrol or diesel. You need the it is going to be costlier na. So contractor, what he will do, he will go for a small solution, simply pour with a rod, or even he will neglect the vibration. If you are not compacting properly, even though whatever the precautions you have taken, you are not going to achieve the strength. So to avoid all these technical problems, Hajim Hokamura, what he has done is, he is developed a concrete which is going to compact under its own weight. There is no need of any compaction. Simply he is given, FNARC is also given some specifications related to this. And here it is a flowable concrete, but self compacting concrete also. See, there are small changes there. If you are anyone using ready mixed concrete, ready mixed concrete is also a flowable concrete. It is also flows similar to the self compacting, because with the easiness in the construction nowadays, whether it is a high strength concrete or high performance concrete, if you add some chemicals, retarders, so that it will be in the liquid state for a certain time, up to 30 or 45 minutes, it is a flowable concrete, but it is not a self compacting concrete. It will flow up to a certain time, but it will not compact. So that difference you have to see between the self compacting concrete and flowable concrete. Up to high performance concrete, all concretes are, if you want, you can make it as a flowable concrete. In the ready mixed concrete, generally they will make it as a flowable concrete, okay. But here the difference is, see, if you see in the figure here, simply they are pouring it, and no need to use any instrument to compact it, because the mixed proportion itself we are going to prepare like that. See, obviously when I want some advantage, definitely I am going to have some limitations on it when I am preparing it. And obviously if you compare the, see, bottom one is the conventional concrete and top one is the self compacting concrete. If you see water cement, water almost same, but if you see the powder cement what you have used in the conventional concrete, equivalent to that or less than that only I am going to use in the self compacting concrete, but the total powder content is going to be more when compared to this self conventional concrete. That's why we are saying it as a powder, not as a cement. We can say it is a powder or it is a binder. Then sand content, if you see, when you compare with the sand in this case and sand is case, there is a slight improvement this value, because in self compacting, actually idea is, what we are trying to do is, whatever the voids are filling created from the coarse aggregate, that will be filled by with the fine aggregate. Again, whatever the voids are there with the fine aggregate, that will be filled by the binder material like cement and other binders. So all these are compacted at the time of mixed proportion only. We are trying to get minimum voids, so for that we are using more fines in the preparation. That's why you see the coarse aggregate content. Particularly in case of conventional concrete, generally coarse aggregate content is going to be more, but here if you see self sand content, fine aggregate is going to be more than the coarse aggregate. That is the small change. And obviously here, in addition to the super nowadays we have the separate super plasticizers for self compacting concrete. Even SP also there is a separate brand. If you ask, we are preparing for self compacting concrete, they will give. And even you have to know, suppose if you are downloading any paper related to SCC, you see the year of publication. Because example, if you take my publication also, I have published starting from 2008 to 2022. I have published the same SCA paper in the 2008. I am publishing now also. But if you see the mixed proportion and the dosages of super plasticizer, doses of VMA, there is a drastic change in the value. I am reduced so much now, because now we are using the fourth generation super plasticizers. Earlier it is only third generation, second generation super plasticizer. So there the quantities are going to be very high. Per 1 meter cube, even I have used 10 liters of SP also in the beginning, if it is a second generation or third generation. But now we are using the fourth generation super plasticizers, and their dosage also very less. Now maximum of 1% SP is sufficient for preparing these self compacting or regular concretes. Okay. And one more thing we are going to add here, that is called VMA, viscosity modifying agent. So that quantity is very less actually. For meter cube of concrete, I may use 0.5 to 0.75 kg, or 500 to 750 grams per meter cube of concrete, like that. But its effect is very high on in changing the property of see, when I am developing a self compacting concrete, basically three things are important. The thing is passing ability, flowability, segregation resistance. These three things are important. We are going to pass, or we are going to say any concrete which is going to be passed means passing ability, flowability, and segregation resistance. So initially we are going to have the fresh concrete properties. So to get the less fresh concrete properties, there are some limitations: 50% of solid volume, then 40% of motor volume, then high doses of SP, low water cement ratio. All these things we are going to maintain here to develop these. And obviously if you see the mechanism of achieving self compactability, the interaction between the motor and aggregate, definitely there will be a paste in between these. So how much paste is required here, how these are affecting the in developing the self compacting concrete, all these things we are going to see. Basically I will show one thing here, how we are going to develop the SCC. uh, so before that, just you see the application of it. See, Akashi Kaiko bridge, it is completely developed with the self compacting concrete. If you see here, because it is developed in Japan, Kaiga project, that is also from the self compacted. Simply you have to pour it. And particularly what happens, whenever you are thinking about a high strength concrete or high performance concrete, definitely there the reinforcement level is also going to be very congested. There no chance of compaction also. Even if you think, okay, my budget is less, I want to go for a normal concrete, but there is no chance of compaction. So that's why there is no alternative other than self compacting concrete. Because what happens, you see here, I will show some example. Let us see this figure here. If you see this pier, the reinforcement is very congested, even there is no chance to compact it. Obviously if there is no chance, you see here there is a gap in these materials. So because of that there is a failure. So that's why always in the particularly congested, when you are constructing the bridge piers, abutments, embankment, and all these, definitely there the requirement of steel is very high, and obviously it is going to be congested. So in these all these cases, self compacting concrete is going to be very good material. Okay. These are some benefits. But I will say, what is the constitute material we are going to use, and what are the basic properties, basic test what we are going to see, I will tell you. So obviously here it is a combination of steel, cement plus additions, like some binders, then aggregate, admixture. Even if you want, you can add a fiber reinforced also, no problem. Otherwise, you can develop a self-compacting concrete. But here, FNARC guidelines are very, very important to develop all this. These are the regular materials what we are going to use. That is already told with you. But FNARC is given some specifications particularly to develop the concrete. Even it is given some limitations. Example I will tell you, there should not be generally cement. What we will say with respect to our IS code, we will give the maximum limit, but here in SCC they have given a minimum limit also. Minimum 400 kgs of powder is required to develop any grade of concrete. Without 400 kgs of finer material of powder, I am not saying cement, I am saying the finer content, whatever you are taking in the form of a cement or binder, that should be a minimum of 400 kgs and above. Then only you are able to develop the self compacting concrete. Then there is a limitation on the water cement ratio. Then there is a limitation on the water also. They says in no case you should not go more than 200 liters of water per meter cube of concrete. 200 kgs or 200 liter, because for water liter or kg is same, because if the density is same. Okay, and like that so many limitations are there. If you follow that, then automatically you are able to get the self compacting concrete. But how to check the suitability? Then how I can say it is a self compacting concrete? For that, FNARC, European Federation, is given some guidelines, that is called FNARC. It is revised in 2005. After that also some revisions are there. If you type in the Google just FNARC specifications, complete booklet in the PDF form you will get. So in that they have given this test procedure. Actually, when I am preparing a SCC, it should pass these three tests. It should pass. One is passing ability, filling ability, passing ability, resistance to segregation. That means filling ability means, suppose if I am filling in a any because here also we are going to do the workability test na. So let us say example, suppose if I am filling in the cone and if I am removing it, it should flow on its own weight. That is filling ability. Then one is filling ability, then passing ability. Passing ability, let us example I will say, if you have a j ring, so this with the j ring I can say it is passing the passing ability. Passing ability means if some obstruction in the form of a reinforcement also it is coming, even though it should pass through that obstruction without any problem. Inside the ring, outside the ring, if you measure the height of the concrete, it should show the same. Then I can say it is passed about the passing ability. Then with respect to resistance to segregation, resistance to segregation means actually we will use that by using this V funnel test or J ring test. I have to pour the concrete in this V funnel first. Then here we are going to have a knob and opening arrangement. If I open this door, then the concrete is going to be completely um, coming out from this V funnel, and it is emptied. So the emptying time of this V funnel is given as 6 to 12 seconds. Suppose if I am starting that mission, when I am going to open this nozzle, so it should be completely cleared this V funnel within 6 to 12 seconds. Then I can say it is a self compacting. Passing resistance is there, and this is a passing ability test. It is passed. After that, what we have to do again, we have to fill this V funnel and we have to kept it. Then after that I have to wait for 5 minutes. Then after that I have to release this knob. Then at that time, maximum of it may take 2 to 3 seconds extra. Suppose earlier if it is taken 10 minutes 10 seconds, now this time it may take 12 to 13 seconds. If it is within that limit, then I can say the main idea here is, see, I am pouring it in the V funnel. I am and waiting for 5 minutes. Means during this 5 minutes, it should not stick on to the walls of the this, and there should not be any problem with the segregation resistance. If it is sticking to the walls, obviously it will take so much of time. If it is not sticking, there is no problem with the segregation, then it will come out as a liquid. So that's why we will check at 5 minutes. Okay, So similarly, L box, U box, all these are there. Basically our idea is it should pass these three tests. One is passing ability, flow ability, passing ability, segregation test. If it is passing all these three tests, then I can obviously I will say it is a self compacting concrete. So I told you already some FNARC specifications are there for these. So these are the FNARC specifications for slump flow, T550 slump flow. Then jaring means the difference of height between inside concrete and outside concrete should be maximum of 10 mm. Then V funnel also 6 to 12 seconds already told you. T 5 minutes means plus 3 minutes 3 seconds extra it may take. Similarly U box also, when we are releasing from the U box, actually the height difference, because here it is coming is in the horizontal level. Let us say if I am saying this side as H1 and this side as H2, the height difference should not be greater than 10 mm. So like that, some precautions are given, some test data is given in the FNAR. If it is satisfied these three conditions, then I can say it is a self-compacting concrete. So we thought initially we started with the lime mortar, then we came to the cement, then we came to the high strength concrete, then we came to the high performance concrete, then I again we came to the self compacting concrete. But for a self compacting concrete, practically if you say for small quantities you cannot do, definitely batching plant is required, because compactability should come from the mixed design itself na. So it is not that much easy to prepare it manually with the small quantities. Definitely batching plant should be there, there should be a transportation system to the material, then pouring system, pipeline system, everything is required. So still whatever, okay, technically you are able to develop a good material, but the problem is if you see from the environmental side, still you are not you are using the cement, you are using some good amount of cement. Then if I am using the cement, see I am preparing a construction means cement means indirectly I am developing carbon dioxide. So environmentally there is a burden, even though some part of the fly ash, ggps, these things you are using, and some environmental friendly materials you are using in the form of replacing the sand, replacing the coarser grade and all that. But mainly there is a burden on the environment. You are you have to think in the direction of sustainability. Sustainability best example I will say, suppose let us say now if you are getting the nowadays 500 ml bottle for 10 rupees we are getting it. At least this you have to maintain for your future generation also, and your people, your children, grandchildren also able to get the same rate at this water after 20 years also. Then I can say I have maintained the sustainability. Suppose let us say example I will say, when we are the childhood, if you take long back 20 years or 15 to 20 years back, everyone is going to use the municipal water only, no one is going to purchase the water even in the cities or even in the villages also. But nowadays even if you go to the villages also, you may get other things but you may not get a water at free of cost. The thing is, the problem is what we are doing is in the form of the industrialization, all the resources, whatever the natural lakes, natural rivers, natural tanks, whatever we have, we are throwing the waste in the rivers, in the canals from the industry. So there is no guarantee that if you drink the water directly, then it is harmful to you. But earlier days it is not like that. Simply whatever the water it is coming from the canals, that they are going to take in the municipality, seems some bleaching they are going to add it, and they are sending us, we are drinking the municipal water. But nowadays if you see, no one is going to drink the municipal water, everyone is using the can. The reason is there is no guarantee, there is no such harmful mixes, chemicals are not mixed in the regular water which is freely available. This is because of the industrialization, and this is because of the not caring about the environment. See, as an engineer we have the responsibility to take care of this environment. You whatever the technology you develop, it should be environmental friendly. That's why now after having this much of development also, still we are not satisfied with the self compacting concrete and all that. Self curing is also there. Self curing is very simple, similar to self compacting, but the thing is, here we are going to use some self curing agents. Some agents we are going to use here. Let us say I will give you the example of liquid paraffin wax. Light is there, heavy is there, so some dosages we are going to use this self curing. Mainly what happens, I told you, now the drinking purpose only we are not able to get the water. Then from where you will get the water for curing purpose? Because you have to use the potable water. It should be a clean water, almost drinkable water. So now that water is not available everywhere, so that's why this self curing concept is came into picture. By it can maybe internal curing or external curing. If you add some a curing agent to it, it will take care about it and no need to worry about it, because there is no water to cure it for 20 days or 40 days. How you can cure it? So that technique is also came now. Even if you see the L&T, it is constructing in Hyderabad, whatever the metro works it is doing na, all there they have used simply this self curing agent. Simply they are going to prepare the piers and all these things they are leaving. If you see, simply they are going to have a epoxy coating. Whatever the water it is added in the initial stage for the water cement ratio for the hydration process, the same water is maintained for 28 days for this to go through this hydration processes at a lower constant temperature, because you have to maintain the temperature at the hydration process. That's why you need the water. That is the main thing. So during hydration process, though there is so much temperature development, to you have to control it. That's why we are going for different types of curing. But here, if you go for this epoxy coating like this, whatever the water is added in the initial stage, that is going to be there and it is going to take care your curing part. Okay, so this is also one of the development. But I am not going to say about much more about the self curing. I want to discuss geopolymer concrete because it is a very good idea. See, now still now also, whether it is self compacting, self curing, anything, but you are using the cement and you are harming the environment. Once I am using a cement means indirectly I am producing carbon dioxide, greenhouse gas problem will come, then so many problems will come. So try to avoid utilization of cement. This is called no cement concrete. So in the geopolymer concrete, actually we are not going to use any type of cement. Simply there we are going to use this alkaline binders, and there is completely replacement of this Portland cement with fly ash and GGBS. We are going to develop a environmental friendly concrete by utilizing this from the geopolymerization process. Actually mainly here we are going to use a process involving the synthesis of geopolymers, which takes place through plenty of process such as leaching, diffusion, reorientation, polymerization, and setting of mononorms into polymeric structure. So instead of staying technically, I can say here we are going to use two things: sodium chloride or potassium chloride, or sodium NaOH, Na2SiO3, or sodium chloride or sodium hydroxide. These two things are used in the preparation of these uh, geopolymer concrete. Actually what I am going to do is I am trying to use some binders in the form of fly ash or GGBS, and I am going to use some alkaline solution, and from this I am going to develop this geopolymerization and geopolymer concrete. So in this this is going to be said in the form of the molarity. Suppose if I am using some NaOH, you know that NaOH is 40 grams, Na is 23, oxygen is 16, H is 1, total is 40 grams. So if I want to prepare a 1 molar of NaOH, means for 40 grams of NaOH, I have to add a distilled water of 1 liter. Similarly, if I want to develop a 10 molar, let us say 10 molar means 40 into 10, 400 grams of NaOH if I use, and if I add this 10 liters of water, then automatically I can prepare a 10 mole NaOH. Because with respect to molarity only, we are going to say about these alkaline solutions. We have to prepare the alkaline solution and this alkaline solution is going to react with the binders like silica fume or fly ash. This reaction, geopolymerization will be there in between. No hydration process is there in geopolymer concrete. And simply, actually, if you are go on increasing the molarity, it is going to be very good. Obviously, if you are increasing the molarity, then you are going to see the best results. But the thing is, there is a problem with the workability. If you go on increasing the molarity continuously, there is a problem with the workability. So that's why generally 10 to 12 motor, 10 m or 12 m motor we will use. 10 m or 12 m uh, molarity can be used in the preparation of the geopolymer concrete. And I can say that because this is a new area, and even you, whenever you are developing any new thing, you can go for patenting it, or you can start some selling these mixes. When I developed this self compacting concrete as a research scholar in the NIT Warangal, we have given mixes to the Lanco on payment basis, that is consultancy. We have done consultancy. We have given the mix proposal starting from M20 to M60. So they paid for each mix, they have given 1 to 1.2 lakhs for each mix. So nowadays, whatever you are learning, whatever the technique you have to do the business, or you have to sell it. You have to sell yourself. So that's why, not only research, after doing this research, you, if you feel that it is a patentable, then you go for patent. Example, I will say, in the geopolymer concrete, actually generally in the geopolymer concrete, we will use the fly ash actually, because fly ash is plentifully available in India. But the problem with the fly ash is you have to go for elevated curing. Means hot, at a higher temperature only you have to go for curing. But in practicality, if you want to develop the geopolymer concrete with that elevated temperature, it is difficult. So we have given a solution, preheating of preheating technique for developing this geopolymer concrete by using fly ash itself. So with that, we went to this IP portal, and we have claimed a patent also. Now I have a patent on the how to develop a fly ash based geopolymer concrete without going a elevated temperature. For that, because that we have trialed in the research lab and we succeeded, we have filed it as a patent. So if time permits, in on any other day, not today, we will have a plan to discuss about how to do the innovation, what are the innovation techniques if you are doing any innovation. Because one some work you have done means that should be published. By publishing also, you will get the citations, and you will become the popular. See, after doing some consultancy research, you should do consultancy, or you have to show yourself. See, suppose you have done some new work, then you publish it. Otherwise, before going to publish, if there is any some chance of business is there is a chance of doing some uh, this startup program or like that, then you go for patenting it. If you take a patent, then they will come to you to know the proportions and all that, to know the method. If anyone wants to that method, they have to take permission from you if you take the patent. Even you can start a startup also by using all these new techniques. So nowadays, for a civil engineer, so many chances are there. But the thing is, you should be updated. You have to update. See, I have started my research even with Ramprasad sir also. We started our research long back, 15 years back, 20 years back. But still we are working, we are updating. I have developed a SCC in 2008 or 2010. Still, if I sit calm, then I cannot survive. After SCC, then after coming in the NIT, already, even though I am working as an assistant executive engineer in a government sector, but I went to the college in the where sir is working in Karnool. So I am taking the classes there. I am helping them. One side I am helping them, in the other way I am upgrading myself. So just the leisure time I utilize. Then after, because of that grip in the teaching, again I got selected in NIT. It is not that much easy to select in NITs. Even though you have a degree, PhD, but they will ask so many things. You are in the field, how you are connected, what is the grip in the subject, how you will do the research like that. So those so many questions they will ask. That's why I was in contact with the college and I am doing some research also there. I guided some students. They have done some new research works there. We whatever the SEC we have developed for that, again we have replaced the sand, we have replaced the coarse aggregate with the recycled aggregate. So the research means research. You have to think a better alternative. Only nowadays, see, sand is also a very big problem. Even the cost of the sand is triple when compared to last 3 4 years. So you have to think for the alternative, because these are natural resources. If you think sustainability and environmental friendly, definitely your responsibility for alternative materials. Continuously if you go on using the sand and coarse aggregate, how many days it is available? Definitely one day it will come, there is no availability of cement or no availability of sand or coarse aggregate. So think for the alternative. Even nowadays coarse aggregate is also replaced with so many, not only recycled aggregate, even by using the fly ash also they are preparing pebbles, and these pebbles are used as a coarse aggregate. So like that you go on doing research, and you that research should be environmental friendly, and you keep the mind the sustainability concept, so that automatically you will click, and you go on doing the research. Then another thing is, we as a civil engineer we have so many opportunities. If you want to work in the private sector you can work, or if you want to start your own consultancy also you can start, because so much of construction activities are going on around the cities. So you may start 2 3 people can become partners and they can start the consultancy. Or initially you learn the things 1 or 2 years in the site, then you start yourself, you become the, see, after completing the btech you can get the license of surveyor. If you get the surveyor license, at least you can prepare the plans na, you can give to your neighbors, your relatives also. After that if you finish your mtech, you can get a licensed structural engineering license is there. Even I am saying, if there is no job opportunity from the government side also, you can create your own job opportunity. Take a structural engineer license after completing your mtech, then it will give you minimum of 2 3 projects. If you do also from the structural engineer, you will get so much of money. Even if you execute the projects you will get the money. Other than that you can work in any design field, you can get the money. But the thing is, you have to update yourself, you have to learn the new things, you have to learn the basics. You should be strong in the basics, but you have to know how to use these known things with the new technology. See, best example I will say, we have developed the self compacting concrete in the 2008 or 2010 only. But after that if you see, I have published a paper in 2016 or 17 by using the ANN technique. That means whatever the self compacting concrete I have developed earlier, for that I have done so much of experimentation. But now I did not done any so experimentation, simply by using the ANN technique. With the existing data I have prepared the samples 100%, and out of that 70 I have given training, with the 30 I got the results. So it is going to give the best results. With that I published a SCI paper. It is not a it is not that much easy to publish a scopus in scopus or a science citation indexed paper. So I have published it, because you have to upgrade yourself. And always you people try to attend some workshops, conferences, or you try to observe in the observe the construction, what it is going on around you. Should be, because practical knowledge is very very important than the theoretical knowledge, and that too with the soft skills. See, there are two things. If you want to work laboriously, or you want to work a smart man, smart worker, a labor worker, the difference. See, smartly you have to complete. Best example one I will say, then I will go to our topic. See, if you see AR Rahman, if he is giving music to one project or one film, minimum he charges 1 crore. But how much time he will spend? A maximum of 1 month. But when he is learning the subject, or when he is having the grip in the subject, he is learned like that, and he is going to give his music in such a way that everyone will enjoy with that. But that like that smartly you have to act. You should concentrate in one area. You take only one area. I am not saying you should be a master in all the areas. You take only once. You see in which area you are strong. As a civil engineer, which subject is very much interested to you, or whether you are interested in the geotechnical side, you are interested in the transportation side, you are interested. So everyone should not be a structural engineer, everyone is not going to be a surveyor, everyone is not going to be a transportation. So you see in which area you are interested, in that area you go into deep, you go into deep, then definitely you will become the master. Because laboriously if you do so much of hard work, and you finally if you are getting a 10,000 or 20,000, 40,000, it is useless. You work smartly. Smart working system you have to develop. Okay. Otherwise what happens, you go, if you are not very good, of course you will get a job. But if you are not master in particular area, if you are master in a small area, so best example I will say, one of our friend, he knows only AutoCAD. He is very strong in AutoCAD. Any diagram within 5 seconds, 5 minutes he will finish. In that we have a 3D tool, one 3D tool is there, maximum of 15 to 20 commands are there. He is master in it. Now he is sitting in Hyderabad. Per day he will get minimum of 15 to 20,000, because he is giving elevations, but he is continuously learning the AutoCAD. Not only 3D, not only whatever the updated versions is coming, only two tools he knows perfectly. Edit tool, draw tool is there, in that all the 3D options are there, but he is master in it. Any elevation if you want, he will give in 5 to 10 minutes. That much of command is there in that AutoCAD. Orbit is came now, so much updated versions are there. He is very strong in that. He is not bothered any AutoCAD design, anything he know, but he knows in drawing a 3D elevations. He is a perfect man. Now per day he is getting not less than 20 to 30,000. Some people, what you will think, AutoCAD what it is, whatever it may be, you should be master in it, then you are going to be success person. Similarly, you are doing learning so 40 to 45 subjects you are learning in the, why we are giving all this, you can ask, sir, why all these things? Because as an engineer you should have a common knowledge. Even if you see some basic electronics, then computer science, all these subjects are given in the first year. Because as a engineer you should have a common knowledge in all other areas, but in one particular area you should be strong, right? So like that, we whatever you learn, you focus, you learn it with the confidence, right? See here, we have also developed this geopolymer concrete, because I have to think for a concrete which is going to be environmental friendly. So in that way we have done a research and we developed this concrete, geopolymer concrete. Another problem in the geothermal concrete, already I told you, if you are using the, if you are developing the fly ash based geopolymer concrete, obviously what happens is you have to go for elevated temperature. But without that, how to do? With in that direction we have worked, and we got a patent. Okay. So there are so many ways of getting a patent. If possible on any other day, what is how to patent any product, then what is startup program? Because from our institute side, I am the ambassador for institute innovation cell. So ambassador means, see, there is no need to do all this, but I am upgrading myself. I am in contact with some other institutes like you in private colleges. I have contact in Bangalore, so many colleges. Because from this institute innovation cell, we are sharing our ideas, we are training them also. Whatever the knowledge I have, I am sharing with them. We are sharing with the students. Even I am giving startup trainings. We are having a startup program also here. So nowadays what government is saying is, even though ours is a government college, but they says in future you have to sustain on your own, we are not going to give any money. They are clearly declared. Now NIT, okay, we are, they are paying the salary, but afterwards the target is they are going to say self sustain. You have to develop your budget. How we will develop? Through consultancy, through startup, through IP, this patent, I can sustain myself. Simply they now they are going to say they are going to pay hourly basis. Suppose if they are contacting me for 2 hours per day, that much of money only they are going to pay, and they are going to say that is your wish, you do any business after the 2 hours, we are not having no problem. But you are no longer going to be a permanent employee of any individual institute. That is the future coming. So that's why you have to update yourself. No one should think about any government job, because nowadays no government job is required. If you have the skills, automatically you can shine. Indirectly all our civil engineers are businessmen only, but you have to do the business, a smart business, not a laborious business. Okay, so you develop whatever may be the subject, but in that area you should be strong. A small area you take, you should be a master in that. You take a AutoCAD, you take a STAD, but you should be a perfect man in the STAD. Then automatically any company, they will call you, and if they give you a problem, if you are able to finish it within 10 to 15 minutes, they will like you. Even it may be a STAD, it may be a MATLAB, or it may be a ETABS. So you should know the application of the known knowledge in the smart way, not in the laborious way, right? So here, this there are some curing methods. Already I told you, hot oven curing is there, then steam curing is there, ambient curing is there, preheating technique already I told you. So because if you go for hot oven curing or steam curing or ambient curing, actually this is also one research we are doing. Only with the fly ash it is not possible to get the strength in the ambient curing. So what we are doing is we are replacing this fly ash with the 100% GGBS is also not suitable. There is a problem with the workability. So we are trying to make a optimized dosage of fly ash and GGBS, so that at what level I can get, even at a ambient curing, if I want to get the geopolymer concrete, what I have to do. That is the research we are doing here. Now my research scholar is doing the same thing. So even with that we are publishing also. Okay, so you should be, whatever may be the area, you go on continuously working on it, and you become a master, so that even a civil engineer is having so many opportunities nowadays. See, right now a geopolymer concrete is developed with the, mainly here two things are there. One is binder, another one is a solution, alkaline solution. So there is a alkaline reaction is there, geopolymerization is going to happen instead of hydration process. And because of this geopolymerization, actually water we will add a extra water will be added just to get the workability, not for, it is not at all related to the strength. Okay, so some water is also added here, and some publications also there here, sir. What I want to do is, if they are interested, we will take 5 minutes break. Then I want to show the, till now we have discussed only innovation in the concrete, but I have some innovative techniques of this construction activity. 5 to 10 minutes, but I think continuously we are speaking. So if you permit, I will take 2 to 3 or 5 minutes break. Then 10 to 15 minutes we will discuss about the another topic, like innovations in I will show that also. Is it visible, sir?
Yes, sir. Yes, sir.
Yes, sir. You can take.
Visible, na?
We will continue after 10 minutes, sir.
Yes, sir, we will continue after
Ah,
5 to 10 minutes. Some
okay.
important techniques are there, that we will discuss. Okay,
Okay, okay, okay.
okay, thank you.
Okay, sir. Please, be seated. Just, అందరికి ఈ టైం రాదు, వాళ్ళు మనకు అవైలబిలిటీలో ఉండరు. ఈ రోజు ఈ ప్రోగ్రామ్ కండక్ట్ చేయడానికి దాదాపు 10-15 డేస్ నుంచి ఎఫర్ట్ చేస్తే కానీ మనము ఈ ఈ స్టేజ్ రాలేకపోయినాం. సో మీరు మీ అవసరాలు అందరికీ ఉంటాయి, బట్ getting the estate person for your delivering of these new things
Hello, hello, sir.
Sir, you can proceed, sir. And one more thing, that the link will close by 12:30, sir. You can try to complete before the 12:30.
Okay. Yeah, yeah.
Okay.
By 12:30 we will close. No problem. Right. Yeah, is it visible?
Yes, sir. It is visible. It's audible, sir. You
Okay.
can continue.
So now,
Okay, 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 sir.
see now what, because knowing the subject is one thing, and you have to sell it. See, for that nowadays we have this Institute Innovation Council, Ministry of MHRD, uh, Minister of Human Resource and Development. Every institute they have this institute innovation cells, and under that we are going to train the students how to prepare the incubation centers or innovation centers, startup programs, and all that. So even with our innovation of construction techniques, so many innovative techniques are there nowadays. 3D printing is came into existence. See, earlier 3D printing we are thinking, is it possible or not, but it is not. It is also possible now. Now you can go for a sir, the slides are visible now. Slides are changing.
Yes, sir.
Okay.
Innovation, construction technology, it is appearing.
Yes, sir. Yes, sir. That one only. Thank you.
Okay.
See, our government idea is also pakka houses for all the people, and even they are going to use this Pradhana Mantri Awas Yojana not only for the poor people. If you see that is I want to say, you have to know the what is the feasibility. Suppose example I will say, we will think that this housing for all is only for the poor people. It is not like that. If you go to the website of Pradhana Mantri Awas Yojana scheme, there are so many ways, so many number of schemes. If it is urban, a separate scheme is there. If it is village side, or if it is mandal level, if it is in gram panchayat, like that, so many different schemes are there. Even a government employee is eligible to get a house from this scheme. Okay. So like that, you have to know the what are the techniques, and what is the facility it is available, right? I think some problem with the network. Hello. sir, okay, okay, no problem, no problem. Right, right, right. Mm-hmm. Okay, sir. Right. Yeah, I think now it is okay.
Yes, sir. Yes, sir. It's okay, sir.
Can you hear me? Yeah, yeah. We will continue. Okay, right. So what I want to say is, government is planning for housing for all. So under that they have given so many Pradhana Mantri Awas Yojana, Pradhana Mantri Awas Yojana, urban is there, Pradhana Mantri Awas Yojana, Gramin is also there. So under this they are going to construct these Pakka houses for all the householders. So this is an opportunity for us to get. So if you are able to construct a small house with at a low cost, definitely government will encourage you, and indirectly we are encouraging the society. So in this nowadays, even they are in some places they are going for the 3D printing technology also for preparing the house. Now you can utilize the 3D printing technology also. But we will see what are the different new innovative techniques to develop all these constructions. See nowadays, see here, if you see this construction, it is G plus 3. So if you want to construct the G plus 3 in our regular framed structure manner, but it will take so much of time and so much of cost also. But even if you see this Rajiv Gruhakalpa or Pradhan Mantri Awas Yojana or Indiramma houses, whatever the house construction now taken care by the government, I think in Andhra also, L&T is taken this project. Simply they are going to construct this works without any framework. Simply this with the load bearing walls only, just like the frame they are developing, and they are going to fill the walls also with the concrete, but with a lower grade. See, if I am preparing the wall with a concrete, no need of that much of quality na, whatever the strength it is required as a compression member, because wall means it is a partition wall only. So like that, as a load bearing wall, nowadays they are going to construct these new techniques by going for the latest options. So now we will see what are the different latest techniques we are available. First we will see housing, how it is started. Basically housing is started with the old construction technique like mud houses. If you see earth house is the beginning. So many of you have seen, and now still also you can see in villages or uh, in the, if you go through the forest area, now also you can see this mud house with the this type of roof covering. So that is the starting of the house. And even at that time no brick or local, everything is locally available. So with the earthen house, they are going to construct that, but they are very user friendly, and the no need of any cooler geeler like this, because they are going to be very cool, because it is a made with earth. After that, we came to the wooden houses, constructing the house with the wooden planks, because in some areas only constructing with the mud. In suppose if it is a cold environment, the temperature variation, you cannot maintain the temperature variation with the mud earth house. So obviously, if I go for the wood based construction, then even in the cold areas also I can sustain the cold. So like that, slowly with the locally available material, we started with earth, we started with this. Then slowly when we are upgraded, then we came to the stone building also. It is a development, like just like our even in nowadays also, if you see in the villages, we can see this stone houses, right? Then after that, we have this brick and unreinforced brick masonry construction. That means we are after the stone, then brick is came into existing. So that is the, see, initially we use the mud, but we don't know how to process it in the form of a brick. So just because of the upgradation in the research, the same mud is used in the form of a brick, but having some standard size, burning it. So some technology we have developed, so burnt clay bricks are used in the masonry houses slowly after that. Then still after that also, because with this we can go only single storied or maximum of G plus 1. But after that, confined masonry construction, we are going to it is a masonry with a brick masonry or stone masonry, but with a confined construction. That means in between we are going to provide the steel reinforcement, then we are going to confine it with the some reinforcement, like that. Now whatever the reinforcement RCC structures we are using, they are confined masonry construction only. Masonry means it may be a brick masonry or it may be a stone masonry, but now where no one is going to use stone, because one thing is it is costlier, and another thing is the size of the stone is going to be very high. Because in a framed structure, whatever the partition wall we are going to use, it is only a one brick wall. For one brick wall, if you use the stone, it will take the 14-inch width. Unnecessarily you are wasting the money, unnecessarily you are wasting the space. So that's why nowadays simply we are using the bricks only. But after that, we have the reinforced concrete frames. If you go on multi-storied structures, obviously how the industry is developed from normal concrete to high strength concrete, high performance concrete, particularly in a very costly areas, we are going for the high rise buildings with reinforced cement concrete. But is this is the limit of thinking? No. After that, then we thought for the major construction types, like structural steel frame building. Because see, some places what happens is you want to construct it in the faster rate, and you want to your construction should be for a longer life and with a small amount of time taking, then you can go for a steel frame is steel frame. Even if you see in the airports, wherever you want the column to column spacing is large, you want a big hall or a auditorium like that, then obviously we will go for a structural steel frame. Even if you observe, see, a civil engineer observation is very very important. Suppose if you are going to see a new area, first you see the what type of construction is there in that area. And if you see, even if you see the railway station, or if you see a airport, or if you see a bus stand, even if you see a bus stand also, if you see our Hyderabad bus station, how they have constructed, what technology they have used, how many floors are there, what new any new technology used, you have to, you should have a observation on the construction. Because suppose if you take a auditorium, or if you take a open air theater, or anywhere where the spacing should be more, if you take your seminar also, see, if it is a reinforced concrete structure, maximum of 40 feet they may have given the width of your seminar hall. They cannot cross more than that, because if you cross it, 30 to 40 feet is the maximum. Afterwards, definitely you have to go for a pre-stressed concrete or any new technology you have to use. Otherwise, with a reinforced cement concrete, without any column to column spacing of maximum of you cannot go more than that. 15 meters is maximum you can go. So that's why there is a limitation in this. So to avoid that, I can go for a steel frame. Frame will be a steel frame, but after that I will other members I will construct it. So like that the technology is developed slowly. After that we came to the precast concrete buildings. So elements are sometimes completely the house itself, it may be made as a box itself, then these boxes are keeping at one place, then making a multi-story structure also, precast concrete buildings. Then after that also, these are all the common practices already what we have seen in the practice. After that, now if you see the alternative innovative construction technique, now in place of our conventional farm work, there is a farm work system replacing the conventional farm work, that I will show you. Then again there is a replacement for the brick mortar or brick work with a sandwich panel. Then there is a replacement for the RCC framework with a steel framework. Then there is a replacement for this cast in situ, whatever you are doing this RCC, that is replaced with the precast concrete. Now precast concrete means completely a single room is prepared with a precast concrete. Simply they are going to keep these boxes one over the other and they are going to make the construction. So like that, so many developments are came into picture. Suppose if you take the framework system, there are so many types of framework: traditional timber framework, timber or steel framework, engineered framework, tunnel formwork, insulated concrete formwork, or stay in place formwork. So the formwork, whatever we are using now, that is changed. Now we have seeing a different type of formworks. It may be with a monolithic concrete framework. Now, if you see here in this picture, this is a steel frame. Directly, what I am doing, I am preparing a formwork in such a way that it is going to be a monolithic. That means slab, beam, everything I am going to cast at a single time. So like that, I am going to prepare my formwork and I am going to fill the concrete. That is one way. Then the other way is modular tunnel form. See, if you see, they are going to prepare a modular tunnel, like then they are going to fill up these walls. See, if you see in this figure, modular tunnel means first I am going to prepare the this farm work, then I am going to fill it with the cement mortar or concrete. So these are the modular tunnel form. Directly one floor I can prepare it in a single stretch with the design requirement. First I will prepare the form, then I will fill it with the concrete or whatever the material I want. So that technology nowadays we are using. Insulated concrete formwork. So here you know that this insulated material also we can use in this formwork. So they are already ready made, these things are there. Simply they are going to have a thickness of the wall, outer wall, inside wall. Then they initially they will prepare all this formwork. Then because now I have a self compacting concrete, let us say I will fill it with the, I am going to have the openings also. Simply I am going to prepare where I need the window, where I need the wall. Then completely it is just like your load bearing structure, uh, with framework or without framework, that you have to choose based on the material what you are using. Support with framework also. With framework means I will go for foundation, then column, beam, like that. Then the remaining parts I will fill up with the formwork. Otherwise without framework means completely you can do it. Now L&T is doing this government all projects. They are succeeded in developing up to G+3, G+4 also, only with the formwork. Means all these walls are going to be concrete walls with a light steel in it. The percentage of steel is very less, just like your shear wall. So all this is going to be one floor. They are going to fill with the, first they are going to make the farm work. For the, suppose you want a kitchen, then farm work is prepared. No column, no beam concept, no brickwork. Simply they are going to prepare this farm work and they are making it farm farm work. Then they are going to fill it with the concrete. That concrete what it you are making is by using the eco-friendly materials, so that it is going to be cheaper when compared to with the other materials, right? So like that, nowadays all this, so many new technologies are coming into picture. No need to go for your conventional framed structure, then preparing a frame, then constructing the brickwork, then going for plastering. All these things are not at all required. Directly it is will come a very smooth finish. It will come. No need of plastering, nothing. Simply you are going for painting it. That's all. So like that, now the technology is here. So if you see the sandwich panel, see, earlier what we are doing, we are going to have the framework, then we are going to have the brickwork na. So instead of brickwork, directly these sandwich panels, you are going to make the panel, and directly you are going to fill it with the material. That materials nowadays, so many materials are there. You have to choose a even this 3D printing is also, it is going to do the same. So in this sandwich panel, actually you are preparing this farm work, then in between you are going to fill this sandwich with the appropriate material. So avoiding the brickwork. So if you see this sandwich panel system, first you will prepare the framework like this, and then these are going to have some thickness. So you are going to fill this. First I have to make the frame first, then I am going, this is all they have prepared with a very light cement mortar only, simple concrete, very nominal grade of concrete they have used. And in all the places, no need of steel wherever it is required. And because if it is a single house, single only one floor house, then no need of much steel also. If you are going a multi-storied frame, then obviously, hello sir, అవునవును అందులో ఓకే ఓకే 12:30 కూడా అయినట్టుంది ఇంకా. ఓకే. కనెక్ట్ అయితే జస్ట్ క్లోజ్ చేసేద్దాం అంతే, ఇంకా కనెక్ట్ అయితే క్లోజ్ చేసేద్దాం. ఓకే, క్లోజ్ చేసేస్తా. రైట్ సార్. రైట్ సార్, థ్యాంక్ యూ.
Okay, sir. You can please
హలో.
continue, sir. Okay, sir.
Yes,
You can
yes,
continue.
okay. So now what I want to say is, see, not only learning the basic subject, but you go to the new concepts. Nowadays no one is going to do this regular practice of constructing a framed structure, then going to a brickwork, then going plastering, then painting. That much of time is not available with anyone, and no, unnecessarily it is taking so much of time. So nowadays, whatever the systems we are having, who you have to implement that, the steel framed structure. Even if you see recently, they have extended this airport in Hyderabad. If you see the Rajiv Gandhi airport Hyderabad, they went for a steel framed structure instead of going for a because it will take so much of time if you go for a regular practice. Simply they made the steel frame structure, and over that they constructed this regular practice. So like that, you have to utilize the for all these. Actually one BMPTC is there, and even if you go through the website, so many new technologies you can learn from the website also. This is steel structural system. Directly you can make a steel light gauge steel frame, or you can make a aluminum frame also. You know that for internal partitioning nowadays we are using the aluminum frame only, but earlier it is not like that. So like that, even this prefabricated structural elements also, if you see the metro works, whatever they have done L&T in Hyderabad, maximum elements are prefabricated. Only they are keeping them in the site, and they are connecting them. So like that, you have to go for the utilize the development, and you have to learn the new things. Only new old things will not survive. Now the 3D printing is came into picture. So initially they are going to do the model. Even one house is constructed with by using the 3D printing nowadays in India itself. They constructed the material. So my intention and what I want to say with you is, you people, 2:30, okay, I think it is closed. సార్ అయిపోయినట్టుంది కదా 12:30. ఓకే. ఓకే. రైట్ రైట్ థ్యాంక్ యూ. జస్ట్ మీరు మీరు క్లోజ్ చేసేసేయండి. ఓకే, థ్యాంక్ యూ సార్, థ్యాంక్ యూ, థ్యాంక్ యూ, థ్యాంక్ రైట్ రైట్ థ్యాంక్ యూ సార్.